Station, this is Houston. Are you ready for the event?
Oh, wait. We're ready for the event.
ISS RDC, this is Mission Control Houston. Please call station for a voice check.
All right, Station Boston, do you read us?
The great city of Boston. This is the International Space Station Expedition 71. We hear you loud and clear. We're ready for your questions and for your comments.
Perfect. Thank you so much. Well, hopefully you can hear some of that applause. So yes, I am speaking to you today from the ISS Research and Development Conference with a hotel ballroom full of people whose research that you're involved with every day, as well as people who are aspiring to send their science to space in the future. So thank you so much for taking the time to speak with us. And to kick things off, of course, we're all interested in ISS R&D. Plus, you have a resupply mission coming up soon, which will, I'm sure, keep you real busy. So in that vein, I would love to hear from y'all about some of the science you've been supporting in your mission so far and things you enjoy on board.
Of course, all kinds of cool science and not enough time to talk about it up here. I have two quick things that have been fascinating to me is working with a 3D printer that prints cardiac tissue to try and create artificial hearts. Pretty impressive to be able to do that and hear the excitement in the researcher's voice when you report back the results or show them a picture or show them a video of what their device has been working on, and they just get so excited, and I just love being a part of that. Of course, I'm just the technician moving things around, but it's always exciting to see that happen. And then the bigger part of the research also, as well as we are the experiment. So I'm a part of a study where, we know that a treadmill takes up mass and space, and that might be hard as we go to the moon and we go to Mars. So I'm part of an experiment where I don't ride on the treadmill. We want to see if you can go in space and what happens to your body if you never use a treadmill. So I haven't ambulated or walked since March.
One comment I'll make is we kind of live between these cargo vehicles. Each one of those represents a science surge, if you will. It brings new experiments, and some of those are pretty hot off the press, meaning we have to work with short-lived components and really get on the stick and do a pretty wide variety of science associated with each vehicle. So we haven't had a new vehicle for a while. We're really looking forward to this and rolling up the sleeves and just doing a lot more diverse science when this comes.
I think you have a lot of folks who are very excited to get that cargo on board as well to have you help with that research. So kind of continuing on, I know Matt and Jeanette, I would love to get your perspective for your first flights. What's something that you did not expect, science or otherwise, about life on station?
Well, one thing that surprised me, having done so much research in the past, is how difficult research can be on orbit and the things that you have to think about before you assemble an entire project to do the research. The genetics in space and the really small quantities that we have to work with there and the way that water operates in space is very different. So the thought that has to go into an experiment before we can conduct it up here is probably double the time that I would spend on the ground putting together one experiment. So that surprised me, but it's reasonable, especially when you consider that things just float away. And you got to make sure that your sample is secured to the table before you walk away from it. So there's many things that you have to consider when you're conducting research here in space. So kudos to the researchers who get it right, and they get great results because, they put Velcro on everything and make sure we do it properly. And, those are just some of the funny things, but conducting research here is different than on the Earth, and that is something that I've learned, and it's been a great lesson. And in the future, say, someone else is coming up here, they want to conduct their own research, they have to really consider a lot of things before they do that.
Awesome. And on the other side, for Mike and Tracy, and having a couple more missions there to ISS, how has the ISS changed since your first mission, especially how has the science changed since you first flew?
Well, I could say that during my first 2 missions, I was involved in the assembly of the space station, and utilization or science was just something we were, for lack of a better word, dabbling in. And the change for me has been now that we are assembly complete and we are full throttle on utilization, using this space station as the world-class laboratory that it was designed to be. It has been a joy to see not just the kind of science that's being done, but like Jeanette and Matt had alluded to, the scientists, the researchers, the investigators, the people who have invested so much of their resources and their talent into creating a project that can sustain and bring us knowledge in microgravity and all of the other difficulties that we encounter when we try to do the science in this environment, just as Matt and Jeanette had described. And so it's been a joy to see how we have been able to come this far to use the space station as a platform in many ways, and to watch everybody on the ground use their creativeness to exploit all of the advantages that we have up here.
I know Jeanette already mentioned kind of some of the difficulties of doing science in space as far as everything floating away from you. And I think when you talk to an average person about science, you know, an image of tubes and beakers and lab coats may come to mind. So aside from those difficulties, or maybe with those challenges, what does science look like on the space station? Can you talk a little bit about the facilities that you've worked with, kind of how you've worked around some of those challenges?
Well, I could start. Everyone could add things. You know, being up here is all about zero-G stuff management, and that goes whether you're exercising or brushing your teeth or eating your food or conducting the experiments we do. And you really have to develop those chops to be successful at any of these. Use your imagination. And so that's kind of the lens that we look at all of the science that comes our way. I'll use SpaceX 30 as an example. That was kind of a tidal wave of science when we'd only been up here for a couple of weeks or so. And that, in a way, kind of hit us like a ton of bricks because it was very diverse and the techniques you needed for each experiment were very different. And we were doing these for the first time, and some of these experiments were being done for the first time. So your brain is all over the map. You're trying very hard to get it right. You know that these experiments are years and millions of dollars in the making, and you've got a very excited but anxious investigator or payload developer on the other end. And so you're doing your best to use your zero-G chops to make these things work. And you may be working fluid or combustion or 3D printing or DNA sequencing or metagenomic analysis, and at the end of the day, you're just whooped, but hopefully giddy with success. So that's kind of what I think about when I think about that science surge. There's nothing better than having a really excited investigator on the other end who's really happy with what you've done. But we work pretty hard to make that happen.
No, that's awesome. And I know everyone here appreciates the work you do with the science. Kind of going along that line too, to date, what has been the most surprising or unexpected reaction or outcome that you might have experienced on board? I don't know if you've had any of those quintessential, that's weird, kind of science moments on board.
Well, you know what? We're at one time subjects in this, so we are part of a batch data collection as human subjects, and the results kind of come after a lot of us have been done, and the same with a lot of experiments. But when we're able to kind of look back, I think from a medical standpoint, which is of course my world, we've found some pretty amazing things because of ISS research. Some we were looking for, some we were not. In my first long flight up here, we kind of started unwrapping the whole neuroophthalmic thing, where we're finding a constellation of findings that involve the brain, the eye, neuroophthalmic tract, rather sensitive bits of anatomy. It was hiding in plain sight for decades. We didn't see it until we had the tools and the experience up here. Since then, we found other things like thrombotic effects of reverse blood circulation. We're having to rethink how red blood cells work, how hemoglobin operates up here. We still have paradoxes in cardiovascular circulation. And every few years, we find something. So that's kind of the message here. There are things hiding in plain sight that we just haven't seen yet, and we're going to see. So expect the unexpected when you're getting an experiment ready to come up here.
While Mike was talking there, I actually remembered an experiment we had done that surprised me for sure. We got to float around space station, and we spent quite a few hours swabbing places all over the place. Tracy was swabbing places, and I was swabbing places and putting in the cultures and looking for bacteria and fungus. And we got the results back a couple days later. Mike I think you were sequencing the DNA of that? Yeah. So we're sequencing the DNA of these things and looking at it, picking the best samples out. And some of the places we swabbed were not the places we expected stuff to be growing. Was wildly off for what our guess would be. So there's always surprises around up here.
That is certainly a surprise. I'm sure that was a fun day to discover. Along those, with kind of the activities you do with science, how regimented is your day-to-day for those of us not as familiar with your schedule on board? So how much time do you spend doing science? How much time do you have to yourselves? And kind of what do you do for fun on station?
Well, every day is different, and so you can never say that every day is going to be the same. Only thing we can count on is that we have 2.5 hours of exercise that we have to do. So you have to fit that in there somewhere. But we get up probably around 6:30ish. We have a morning hygiene breakfast, and then we have a daily planning conference that we have in the morning. Then after that, we're off and working. It could vary from working in the SIR lab to working in the GEM on their material science lab, the MSL. It could be taking apart the cold atom lab and getting it ready for downmassing to Earth and then reassembling it. And that could take up to 4 hours straight in doing that. So we could spend the entire morning doing one thing, and that could be taking apart the cold atom lab so that we can prep it. And then in the afternoon, we have to fit that 2.5 hours of exercise in, and then we may have to do an ultrasound on someone's eyes or an OCT exam for eyes or an ultrasound on, the jugular vein or something like that. So the day can vary, but it is filled and packed. Like today we had robotic sims that we had to go through, and this was after I had to process all the blood for immunity assay experiment. So Matt had to draw his blood. I had to process all of the blood, and that took several hours. So the day is filled with stuff that is relevant to maintaining the station, doing the research, and maintaining our bodies as well.
Never a dull moment for sure. Well, starting with ISS and kind of looking out towards exploration. So with Artemis, NASA is looking to land the first woman and first person of color on the moon, using those technologies to explore more of the lunar surface than ever before. So I'm interested in your perspective on other sorts of technologies or research on station that we'll need to prepare astronauts for living and working on the moon and Mars. And what are you most excited about relative to kind of reestablishing a footprint on the moon?
Well, I can start. One thing, the ISS is an incredibly well-equipped laboratory, and we are testing everything up here from the life support systems to exercise countermeasures, but also the ability to do science. And all of these eventually have to become more and more automated and independent so that the crew can handle them by themselves. Right now, we're dependent on sending a lot of samples down to the ground for analysis to interpret results. And just like with medical care or regenerative life support systems, we have to become a little bit more autonomous, more Star Trekian, if you will, so that you have research labs or research capabilities and you can do point of origin science and get results down rather than samples down. So developing that autonomy is also kind of ingrained in what the ISS is doing right now. And, obviously we can't wait to expand a little bit out further. I kind of think of the ISS as a low Earth orbit wind tunnel where we can test all of these systems and not just demonstrate that they work, but field test for long periods of time with the use and abuse of a crew and the spaceflight conditions, and then feel a lot more confident in taking them to the moon and further. And I think that's a pretty critical step for us.
I think Mike covered that pretty good. I think people want to hone in on all the the cool things like the rocket engines or the technology or the fuel transfer from one rocket to another to get to the moon. And those are the big things that kind of stick out as shiny objects. But I think the success of going to the moon and then to Mars will be about all the little details, the little things like how do you make a seal, like the Apollo mission, the seals on the doors to open the door to walk out on the surface of the moon had to work 2 or 3 times. They did 2 or 3 EVAs. We're looking to go to the surface of the moon and do weeks and months and years of continuous stay out there. Those seals need to last that long. So we're up here doing the long duration testing, and the little things are what's going to make us successful.
And I'll just add to that since we have a whole room full of bright minds and forward thinkers, that this may not be so glamorous a topic, but packaging and trash management is something that we as crew end up having to use our creativity to manage here on board. And I can only imagine the space is going to just shrink as we endeavor to go further away from our home planet. And so that's just something that I think looking forward we need to put a lot more thought into in terms of how we're going to manage trash, collect trash, and try to avoid trash.
And I'll just add at the end that the thing that I think we could benefit from is figuring out ways to get the human body to last longer outside of the Van Allen belt and the radiation. What countermeasures can we develop? There's going to be a lot of difficulties, I think, in the human body if we don't, one of the things looking at the DNA, looking at our genetics, looking at different ways to help us sustain our bodies. And, there's a lot more to say about that, but, there's a lot of researchers looking at that as well. So bringing together all of those neat ideas that we see in patent literature and figuring out how we can use that on the moon.
You're definitely speaking our language as far as folks interested in the details of science and kind of hoping to prepare for the future. I know we're coming towards the end of our time here, so just wanted to fit in one more quick question. Do you have any last words of advice for current or future scientists hoping to work in space research?
We all had somewhat different paths to get here. But the first thing is you got to love what you're doing. And I think one common thing amongst all of our different paths is that we're all fueled by curiosity. And I think an astronaut is happiest when they're learning new things and when they're seeing new things for the first time. And I would say that really goes for our researchers, the big teams on the ground that are also crafting the experiments that reveal these new things for the first time. So, find that thing that really sparks your interest, get really good at it, do your homework, just get to know everything you possibly can about it. And believe me, you're going to go down other rabbit trails you didn't know existed because you're going to find other interesting things around along the way. But just apply yourself to something that's really, really interesting to you. Most likely it has huge intersections for everything that we're going to do in our research world. And keep in touch with us for sure.
And I would just add to that any young person out there looking to study science or become a researcher, have their stuff on board here on the International Space Station or beyond, needs to find a good mentor, and plenty of them. And any one of us here could probably fill the rest of the time talking about those people who forged a path ahead of us and then reached out a hand and took us along with them. So go out and find somebody that you admire, somebody that is wiser than you, knows more than you, and try to learn as much as you can from them.
That is a great.
Those are great words, and I know all of us would be excited to give back, hopefully, to the Artemis generation and more generations to come. So that concludes, I think, our event for today. But to the entire crew, thank you so much for your time this morning. We really appreciate it, and best of luck with the rest of your mission.
Our pleasure.
Yeah, it's great to talk to you guys. Good luck. Really enjoy the conference, network, learn things, learn people, and have a great time.
Station, this is Houston ACR. That concludes the event.
Thank you to all participants. Station, we are now resuming operational audio communications.